Benefits of radiation cross-linking for automotive applications is our topic now. We've seen from our previous sessions already how crucial new materials are in the fight against climate change, for instance, and the energy context. Now we'll take a closer look at radiation cross-linking in automotive, speech by Wilhelm Schneider and Dr. Michal Daněk. Michal Daněk has been key account manager for Central Europe at BGS since 2005. A graduate in plastics engineering, he obtained his PhD in 2014 on the influence of radiation on polymer properties. So he's an expert in his own field, and he's going to talk about automotive as well as Wilhelm Schneider. He is key account manager for radiation cross-linking and has been with BGS since 2011. The focus of his previous professional activities was predominantly in the area of technical sales and project management of thermo and thermoset plastics, as well as fiber-reinforced plastic composites. So, two experts, one topic, automotive and radiation cross-linking. We first hear the presentation and then your questions and answers. Please feel free to ask your questions over Slido. Gentlemen.
Thank you, Mr. Horkler, for kind of introduction, and welcome to our session. It's not for nothing that the automotive industry is known as the largest and most flexible innovator in the global industry. We will start today's presentation in a slightly different way by review benefits of radiation cross-linking from the last year presentation to show you that all these benefits are also fully applicable in the automotive industry.
We will also happy to present you an overview of trends and challenges. We will also happy to present you an overview of trends and challenges in automotive resulting from this interesting expert survey. In the second part of our presentation, we will give you an overview of cross-linked parts compared in conventional and electric vehicles and present you application areas where we see potential and benefits of radiation technology in the near future.
Last year, in presentation Radiation Cross-Linking of the thermoplastic and alternative to the high-performance plastic, we detailed investigated and presented the advantages and possibilities offered by radiation cross-linking to thermoplastic materials against high-performance plastics. These added values are also fully applicable in the automotive industry. As you can see here, in the additional to the improved material property profiles of the finished plastic part, you can also save material and manufacturing costs. For example, the total material costs are up to 2 till 10 times lower compared to high-performance plastic, and production costs are also lower.
Today's electromobility is a complex set of values representing the pursuit of emission-free mobility, with the aim of putting the least possible strain on the environment, thus, and the associated sustainable development. From 2035, CO2 emissions from new cars are to be reduced to zero.
These assumptions generate the question: how important are the automotive trends for the year to come? Answer to this important question give us the interesting survey, more of than 100 experts from automotive industry from 34 different markets. This survey was generated by iTastic in October 2021 with the title Global Automotive Trends 2022, Experts and Consumer Insight Analysis.
These 100 experts have ranked the most important future trends. On the first place, they have ranked an expected trend, namely battery electric vehicles. Close behind, they have placed efficiency, safety, and lightweight materials. For all these trends offers radiation cross-linking solutions and interesting added values. However, what we found also very surprising on this study is the 17th position for autonomous driving. From our point of view, autonomous driving should be placed on a much higher position.
Correct. If we look deeper into the details of the topic of the battery electric vehicles trend, results here the three expected main challenges from our point of view. For all those challenges offer radiation crosslinking range of benefits. The number one is the advanced battery technology. The number two is improved charging infrastructure. To this topic, confirmed President Biden this September at the Detroit International Car Show announced funding of $5 billion to build charging stations, which the Infrastructure Support Act provides for this purpose. The number three is lower purchasing costs. As mentioned here before, for example, low material, process, and manufacturing costs.
As mentioned in the beginning of our presentation, we give you an overview of crosslink parts compared in conventional and electric vehicles. For conventional vehicles is radiation technology already well known and in service today. As we can see here, most of the crosslink components are located in the engine area, where high temperatures and aggressive chemical fluids occurred. For example, air tank, pump housing, actuators, covers, seal rings, and so on. An example for lightweight applications are plastic screws, which replace metal screw bellows and saves the weight and cost.
However, the battery electric vehicle have a different drive unit, is demand for radiation crosslinking technology also very high. For example, the demand for high voltage cables, plugs and connectors is much more higher compared to conventional vehicles. But as you can see here also, some components remained unchanged from the conventional vehicle, like plastic screw, gears, lightweight components, and so on. And now we look more in details of application areas where we see potential and the benefits of irradiation technology in the near future.
One of the interesting areas where the benefits of radiation crosslinking is already successfully applied are high voltage cables. High voltage cables have high requirements and demands for usage in electric cars, starting from thermal conductivity, flame resistance, materials, and aging behavior over lifetime.
One of the most important added value of irradiation technology to high voltage cables is, for example, increased resistance to heat, which prolongs the use of the cables and extends their service life. Another interesting area where the benefits of radiation crosslinking can be fully applied are plugs and connectors. Plugs and connectors are similar in requirements compared to cables. They are joining devices with the electric power. However, there are different production technologies, injection molding versus extrusion. Important demands include, for example, flame resistance and stable electric properties up to 140 degrees C.
Another important added value of irradiation technology to plugs and connectors is, for example, increased heat resistance or improved resistance to flammability or short-term thermal load capacity up to over 400 degrees Celsius, which extends the use and prolongs the lifetime also. Another specific area where the benefits of irradiation crosslinking can be applied is in cooling lines. Since there are only a few ways to cool an electric car battery, we see the greatest advantages for indirect cooling systems only with liquid coolant in pipes. Cooling lines are important to cool the batteries from overheating. However, since we have a liquid coolant, we need good chemical resistant, durable and flexible material. Cooling lines has to be lightweight in design and material. This is important to reduce the overall battery weight.
One of the most important added value of irradiation technology for cooling lines is, for example, improved resistance to chemical or reduce crack propagation. A special area is the battery itself, or rather, that its cover. The battery cover is a part of battery system. It protects inner cells from other things like dirt, water, and so on. It also shields passengers from the high voltage parts. One of the most important requirements are protection against thermal runaway, mass reduction, and high resistance against environment.
Added value of radiation cross-linking for battery covers could be, for example, improved flame and heat resistant. Another important advantage is the substitution of the metals with thermoplastic material parts. Lightweight design is an area that has been taking advantage of radiation cross-linking already in conventional vehicles, but also very important for electric battery vehicles. It is important to reduce weight and enables higher efficiency. This will be achieved in using materials with high specific stiffness, like fiber-reinforced plastics. Lightweight materials needs different joining and assembly methods compared to conventional materials. For example, thermoforming with organosheets.
One of the most important added value of irradiation technology for lightweight design is for sure improved adhesion, bonding of polymers and fibers, and of course, higher stretch viscosity. Semiconductors are important for almost every application in many areas of the industry. The contribution of radiation technology is here essential.
Semiconductors are used in almost all electric devices. They are important for most parts in an electric car, like advanced driving systems, battery management systems, and so on. Radiation technology has higher precision and reproducibility compared with conventional processes. In addition, we also improve properties like switching characteristics.
These were just some short examples of possible applications where we see potential and benefits of radiation technology for automotive in the near future. Of course, there are many other applications where radiation cross-linking can add value, and these could be your application. And what tell to conclusion?
From our point of view, is radiation cross-linking beneficial for the future and is suitable for future mobility concepts and supports upcoming requirements for plastic components for new electric battery vehicles.
What is your application? Thank you for your attention.
Thank you so much, Wilhelm and Michal. This was a wonderful presentation showing us the potential of radiation cross-linking in automotive when it comes to stiffness, flexibility, temperature, resistance, all the above mentioned and many, many more, as you said. Fascinating stuff, I must say, for the future of radiation cross-linking in automotive that we touched barely in the morning in the first presentation and discussion. We have a few questions that came up. One is, so if you compare the demands between conventional and electric battery vehicles, where do you see the already now increasing demands in that field?
We now see increasing demands in the field of high voltage cables. You can imagine all electric battery vehicles, there are a lot of cables are used,
right?
And this demand is increasing very well in the near future. And we will part of it. We see this already in our production.
Due to the temperature situation, mainly, I think.
Temperature situation on one hand, on the other hand, of increased diameter, because the high voltage cable needs higher diameter and more isolation. So this is the reason why we're also involved in this material.
Yeah. So the next question is quite fitting. What kind of cables are currently most irradiated?
That was already answered.
Yeah.
I mean, if I compare, we also compared the conventional and the electric car vehicles. It's really visible how the diameter, the cross sections, is increasing.
Yeah.
That means really, this is the requirements of what we tell thermal conductivity. It's the requirement for the high voltage and so on. And really we see that the demand currently is for bigger cross-section.
Yeah. More concrete also question the role of BGS, of course. You presented a lot of interesting areas where radiation cross-linking will play a role in automotive, especially in e-mobility, of course, where it can be applied. In which of those areas are you involved and present already?
We are involved in almost every part we presented today, from battery covers to semiconductors. This is a big advantage of our company. We have a share of every market so far.
Okay.
But the problem, is here in all areas, we are fixed with the NDA. That means we cannot be not so concrete here and to present the results.
Of course.
Gladly we will, but
of course. One of the following years, probably, right?
Yes.
Thank you so much for your presentation and for answering our questions. Thank you for having those questions as well. Radiation cross-linking in automotive. For us, it's time to say thank you to Wilhelm Schneider and Michal Daněk.